Assalamu alaikum dear friends. This is week number 415 and we are going to discuss a very important class of random variables today, which is called discrete random variable. Last time we discussed a type of continuous random variable which is called normal random variable, and I told you guys that it is the most commonly used random variable, or you guys can say that the most commonly used continuous time random variable. There are also other kind of random variables as well, just like exponential random variable, uniform random variable. Okay, kindly take a look over those other random variables as well, because we don't have a time. You guys have an exam in the next week. So I'm starting another type of random variable which is called a discrete random variable. So let us start discrete random variables. Actually we are going to discuss four types of discrete random variables. The first one is a Bernoulli random variable, the second one is a binomial random variable, and third one is a geometric random variable. The fourth one, which is a Poisson random variable, I will also discuss it if I get time in this lecture, because I think that the course has become very the course is very has become very large for you, and it will be very difficult for you to prepare for your exam. So I am restricting this lecture up to geometric random variables. So we will discuss these three random variables today. So as we have also talked about these three random variables in our chapter number 2. I told you that Bernoulli random variable is basically composed of a Bernoulli trial. What is a Bernoulli trial? Bernoulli trial is basically the trial in which you will have two options: either you will get a success or failure. Okay, either you will get heads or tails. If you are calling heads as your success, then and then tail will be your failure as well. Okay, so similarly, if you have a dice and you are throwing a dice, so if you call 6 dots appearance as your success, so appearance of any other number or any other number of dots will be your failure. So there is a chance 1 by 6 a chance of your success, and 5 by 6 chance of your failure. Similarly, in many situations like picking a person who has a COVID-19, if you call it a success, then the person who, if you pick a person and test him and the test got positive, then it is also a Bernoulli trial, and success is the success is basically a person who is affected by COVID-19. Okay, this is basically Bernoulli random variable, and Bernoulli random variable is composed of two types. Either you will have a success or either you will have a failure. The second random variable is a binomial random variable. I am going through these three random variables. I am giving you guys a very quick overview of all these three random variables. I will explain it. I will explain them one by one in every slide. But before going and diving deep into the random variables, discrete random variables, I am giving you guys a very quick overview of all these three random variables. Okay, so we have covered the first one. Now we have a binomial random variable. What is a binomial random variable? Again, we have also discussed it. Binomial random variable, just like if you have the number of tries, like you have 10 tries, or you are tossing a coin 10 times, and you want to find out that what is the success, or what is the chance that I will get certain k number of successes. Okay, if you are tossing a coin 10 times and you want to find out the probability, that what is the probability that I will get 5 heads out of all these, out of those 10 trials or 10 coin tosses. So if the answer is given to you by this binomial random variable. Okay, this is a very important random variable, and I have told you guys in the last video that it is a discrete time version of a normal random variable. It is available everywhere. Again we have two states here, success and failure, but we want to find out the probability of certain number of successes. Okay, these successes can be of any type. Either you can say that the successes are in the form of a person who is getting a meal. It can also be a success, or you can say that what is the chance of getting, what is the probability of getting 12 plane crashes out of 24 planes. 24 planes are flying over the sky. Okay, so these are basically the probability of these are basically the method of finding the certain number of successes out of certain number of tries. Okay, the third one is a geometric random variable. What is a geometric random variable? Geometric random variable basically shows you or tells you that what is the chance of getting a success after a certain number of trials. Okay, just like you are tossing a coin, and heads is your again success. So what is the chance that you will get a head at the fourth trial or fourth toss? What is the chance that you will get the heads at the third trial, and so on. So you will toss a coin infinitely times and toss it again and again until and unless you will get a success, or you will get heads. Okay, so these are basically the three random variables. Poisson random variable is again a type of binomial random variable. But what is the difference? The difference between these two is that in Poisson random variable, you have very small number of steps. You will decrease the steps into very smaller number of portions, and then you will have you will get alpha as your average value, which will be equal to n of p, and then after that you will find the probability of different events which are occurring in any state and space. So if you have time, we will also discuss Poisson random variable as well. So let's discuss Bernoulli random variable. So Bernoulli random variable, as I have told you guys, that the Bernoulli random variable t can only take the value 0 or 1. 0 can be a failure and 1 can be a success. So the sample space of this random variable, sample space can be s of t is equal to 0 and 1. It will compose of just two events, which can be 0 and 1. 0 is a failure and 1 is a success. The PMF of the Bernoulli random variable is the probability of the event t will be p if the event I have is 1, otherwise it will be 1 minus p. If the event I have is 0, we can also write this 1 minus p as q. It is also written as q. So the probability of the failure is q. Okay, we can also write it that the probability when trial is giving you 0, so the probability of that trial will be equal to q, and q is equal to 1 minus p. So okay, so this is basic definition of Bernoulli random variable. You can plot it like this: if the probability of success is 0.5 and the probability is failure, which is 1 minus p, or 1 minus 0.5 is 0.5, so the PMF, probability mass function. Okay, another very important thing here is that last time when we were discussing normal random variable, we were not calling that a PMF. Now we are discussing a PMF, which is here. So PMF is a probability mass function, it is used for the discrete random variables. Here we have a separate lecture for probability mass function. Last time we were discussing the probability density functions, which are used for continuous random variables. Okay, so this is used for the discrete random variables, and the probability mass function will be of this type, and the shape of the probability mass function will be like this one. It is a discrete form. It has a discrete form, and you can see that it is plotted like this one. This is for the success probability of 0.5, which is this one. Which is this one. This is a success. One is for success, and it has a probability 0.5, and the probability of failure is again 0.5, because 1 minus 0.5 is again 0.5. Okay, it is because of this formula. Last time you saw that I was plotting all the variables. The probability function of all the variables was like this one, so it is a continuous waveform. That's why this is called a probability density function. Okay, so I think it is clear. Let's move on. The mean of a random variable, you can also find the mean or expected value. You have a formula, which is this one: the event and its probability. All the events multiplied by its probability, and all of them will be added then. Okay, so you have an event 0 failure, and failure has the probability 1 minus p, plus you have an event success, which has the probability p. Adding them together, you will get expected value will have a value of p. Okay, so this is basically the expected value of a Bernoulli random variable. Let's move on. This is the variance. The variance of a Bernoulli random variable can also be found out by another formula, which is listed here. This is again a very important formula, and the proof of this formula is in your book. Okay, kindly take a look over this formula, and this is very important. The variance of any random variable can be calculated as the expected value of the square of that random variable minus the square of the expected value. This is the square of the expected value. Now you can see that this is the expected value, its overall square, and the square of the expected value of the square of the random variable. So it is written like this one. Okay, you can see that here the event has the square. All of these are written here. Similarly, this is written here because we know that the expected value of a Bernoulli random variable is p. So squaring it and calculating the other one here, so I will get p minus p square, which can also be written as taking p as a common 1p into 1 minus p. Okay, if 1 minus p is q, so this can also be written as pq. This is the variance of this Bernoulli random variable. So this formula, I am telling you again that this is the very important formula. Kindly take a look over the proof of this formula. It can also be very important for your exam. Kindly take a look over it. I am telling you again and again. Okay. So let's move on. So this is the same thing which I have told you, that by writing 1 minus p as q, it can be written like p and q. So binomial random variable. Now the second type of random variable is a binomial random variable. So what is basically binomial random? Okay. The binomial random variable x is the number of times a certain event A success occurs. Out of all the trials, what is the probability that you will get a certain number of successes or certain number of the events which we call the success. Okay, it can take discrete values from 0 to n. You can have if you have 10 coin tosses, so you can have 0 successes or 0 head occurrences, up to all the 10 trials can give you 10 successes. All the events are independent and you can get any number of successes, any number of heads ranging from 0 to 10. Okay, I think my point is clear now. If you are tossing a coin 10 times and you want to find out the number of heads, probability of the number of heads, certain number of heads from 0 to 10, so you can find it out by using this binomial random variable. So what is the sample space? Sample space of this random variable is written here, where n is the number of tries. If you are tossing a coin 10 times, so n will be 10, and if you want, and k is the number of successes you want to find out. So we have also discussed it earlier, and the PMF of this random variable can be found out by this formula, which is to find the probability of the successes of any number k can be found out by n choose k, and the probability p raised to power k multiplied by 1 minus p raised to power n minus k, where p is the probability of a success or probability of the any event which you call success. Okay. So this is a binomial random variable, and the PMF plot of a binomial random variable can be this one. If the number of trials are 24 and the probability of the success is 0.2, so after finding all the probabilities which ranges from 0 to 24, you can see that the probability ranges from x equal to 0 to x equal to 24. So you can find out the probability of all these events, and then after finding the events you will get, and you will plot the probabilities of the corresponding events, and you will get this plot. Okay, so this is also, you can see that this is like a continuous discrete version of a normal random variable. You guys can see that the average value or its expected value is here. Okay, so what is this? This is the discrete form of the normal random variable. So the next question is how to find the expected value or mean value of this probability mass function. So this is written here that note that when p into n plus 1 probability multiplied by n plus 1 is an integer, just like here. If you write here p is 0.2 and n is how much? N is 25. N plus 1 is 25, sorry. N is 24 plus 1 is 25. Multiplying them together you will get 5, which is an integer. So the maximum is achieved as Pn plus 1 and Pn plus 1 minus 1. So Pn plus 1 you will get the maximum value or mean values at the point, or you will get a peak at 5 and 5 minus 1. This is 5, and you will get the two peaks, two maximum values, which will be at 4 and 5. And it was also true in the previous slide. So we saw that in previous slide we saw that we have two maximum values which are occurring at 4 and 5, because p into n plus 1 is an integer, which is 5. Okay, so if this is an integer, so we will have two maximum values which will occur as Pn plus 1 and Pn plus 1, p multiplied by n plus 1 minus 1. So 5 minus 1, which is at 4. It will have two maximum values which will occur at 4 and 5. Okay, so you can find the maximum values at this point. This is the This is the research item which has been found out by the researchers, and now it has made it easier for you to find the maximum value. There is another possibility that if Pn plus 1 is not an integer, so what will happen? The maximum probability is then achieved at the lower integer value of Pn plus 1. For example, for n is equal to 24 and p is equal to 0.5, the maximum probability is achieved at k equal to 20, k is equal to 12, which is n plus 1. If you have n plus 1 and p, so what will be the value of n plus 1 and p? It will be 0.5 multiplied by the 25. So after multiplying them, you will get 12.5. Okay. So as it has a discrete value, so either you have to move it to 13 or 12. It has, if you will floor it, there is a command in MATLAB which is called floor, and it will downsize this integer value. Sorry, this is not an integer value, this is a float value, and it will downsize it up to 12. And if you floor, if you seal it, this is flooring, and if you seal it, it will move it to 13. So if Pn plus 1 is not an integer value, which is like here, so you have to downsize it, which is 12. So the maximum value will occur at 12. Okay. If someone is interested, we can calculate all the values and plot it and see that the maximum value will occur at n equal to 12. Okay. So let's move on. This is the very important slide which I have explained. So this is the same scenario which we have discussed, and in this scenario you will see that you have seen in the previous slide that the maximum value has occurred at n equal to 12. You can see that here. Sorry, this is not n, this is the value of k. So the value of maximum probability is obtained by the value k equal to 12. So the Bernoulli random variable arises in applications where there are two types of objects. Again, I told you that a Bernoulli trial is basically a trial of success and failure, while binomial random variable tells you the amount of the successes out of certain number of tries. That if you are testing, if you have a testing lab and you are testing 10%, if you are testing 10 people, what is the probability that out of those 10 people you will have 3 corona patients? Okay, if the probability of getting a corona in Pakistan is 0.023, let's suppose this is the probability. So you can use this binomial random variable to find the number of corona affected patients out of certain number of patients. Okay, so this is again a very important random variable. Binomial random variable, let's leave this one and come here. So there is a proof in your book which you guys have to see, and you will see that the expected value of a binomial random variable is n of p, while the variance is np3. You know the formula of this variance, and the formula for finding the variance is, I am writing it again. The variance is the expected value of x square, okay, x square minus the square of the expected value of x. This is the formula for finding the variance. Okay, I have told you to see the proof of this formula, which is in your book. So we have found the expected value and the variance of this as well. So expected value, mean value, is basically the mode 1 of any distribution, while variance is basically the mode 2 of any random variable or distribution. Okay, let's move on. Geometric random variable, again a very important random variable, and we have discussed it earlier on as well, that the geometric random variable is used when we count m number of trials until the first occurrence of the success. Okay, you have to perform the trials until and unless you will get a certain number of successes, until you get a success, sorry, my bad. M can take values in the range which has values from which ranges from 1 up to any integer up to until you will get a success. So the probability mass function of the geometric random variable is this one. Okay, this is 1 minus 3 k minus 1, and if you get a success at the kth trial, so up to k minus 1 trials you got failure, and at kth trial you get the success if p is the probability of the success. Okay, where p is the probability of success in each Bernoulli trial. The PMF decay geometrically as shown in figure below for p is equal to 0.5 is the probability of success 0.5. So after each and every trial, the probability of the success will decay exponentially, which is written here. Okay, at the first trial, the probability of the success will be half. In the second, the probability of the success will become 1/4, and with each and every trial, the probability of success will decay. Okay, you guys can see that what is the probability of getting a success at the fifth trial. It is 1/32. What is the probability of getting a success at the third trial, which is 1/8. So the probability of success with respect to each trial will decay exponentially, and the probability of success at the infinite trial will be equal to 0. Okay, you guys can see that it will decay exponentially, and at last it will reach up to 0. Okay, so this was all about the geometric random variable, which is discussed up till this point. So what is your task? You guys have to solve all the problems related to Bernoulli trials, binomial random variable, and geometric random variable. I'm not going to any topic after this one. So you guys have to ensure that you will learn all these concepts by practicing all the numerical problems which are in your book. You have to again practice all the numerical examples which are in your book. If you guys have any issue in these numerical problems in your examples, so you guys can contact me, you can ask me in the interactive session. So this was the week number 15. We will also discuss the pattern of your paper in the upcoming interactive session. So I hope that you guys will learn all these concepts by practicing all the numerical questions. Okay, I will see you in the next lecture. Thank you so much. Allah Hafiz.